It seems like every developer in the world is getting down with MCP right now. Model Context Protocol is the hot new way to build APIs, and if you don't know what that is, you're NGMI. People are doing crazy things with it, like this guy got Claude to design 3D art in Blender powered entirely on vibes. And just a few days ago, it became an official standard in the OpenAI Agents SDK. If you're an OG subscriber to this channel, you probably know what a REST API is. You might even know about GraphQL or RPC, or maybe many years ago you used SOAP. When I was a kid, the software engineering gatekeepers told me I couldn't be a web developer unless I could explain the difference between these architectures and protocols. Well, now the turns have tabled and these gatekeepers have been utterly demolished because we're all just vibe coders now, embracing the exponentials, pretending code doesn't even exist, and just chilling with LLMs until we get the end result we're looking for. That being said, you can't call yourself a true vibe coder unless you know about Model Context Protocol, which is basically a new standard for building APIs that you can think of like a USB-C port for AI applications. It was designed by Anthropic, the team behind Claude, and provides a standard way to give large language models context. And they're so bullish on this technology that the CEO of Anthropic said he expects virtually all code to be written by AI by the end of the year. In today's video, we'll actually build an MCP server and find out if it can truly make the world a better place by eliminating all white-collar jobs. It is March 31st, 2025, and you're watching the Code Report. Contrary to popular belief, Fireship is still a tutorial channel. In today's video, we'll take a storage bucket, a Postgres database, and a regular REST API, and then connect them all together with the Model Context Protocol. Not only will this allow Claude to have access to data it didn't have before, but it can also execute code on our server, like write to the database or upload files. And people of the internet are already using it to do crazy stuff, like automated stonk and shitcoin trading, industrial scale web scraping, and as a tool to manage cloud infrastructure like your Kubernetes cluster. Speaking of which, to build our own MCP server, we'll need some cloud infrastructure. And one of the best places to do that is Savala, which itself is powered by Google Kubernetes Engine and Cloudflare under the hood. They were nice enough to sponsor this video, but the reason I like their platform so much is that it's far easier to use than something like AWS, but provides linear, predictable pricing, unlike most of the application and database hosting startups out there. And it's free to get started, which makes it perfect for this project. Now, like other API architectures, MCP has a client and a server. The client, in our case, will be Claude Desktop. Then we'll develop a server that maintains a connection with that client, so the client and server can pass information back and forth via the transport layer. Now, in a REST API, you have a bunch of different HTTP verbs that you can send requests to via different URLs. But in the Model Context Protocol, we're really only concerned with two main things: resources and tools. A resource might be a file, a database query, or some other information the model can use for context. Conceptually, you can think of it like a GET request in REST. Meanwhile, a tool is an action that can be performed, like writing something to a database, so that'd be more like a POST request in REST. What we do as developers is define tools and resources on the server, so the LLM can automatically identify and use them when they have a prompt that needs them. In my life, I've been working on an app I consider my magnum opus called Horse Tinder, but as it turns out, swiping left and right was a bad feature idea because horses don't have fingers. So like every other failing startup in Silicon Valley right now, we're going to pivot to artificial intelligence. Luckily, we can leverage our existing data and servers. Like here in Savala, I have a storage bucket, and it contains all of the photos that my users uploaded. In addition, for user data, we have a Postgres database. It has all the profile data for each one of our horses, as well as the relationships they formed together. And then finally, I have a traditional REST API written in TypeScript that fetches this data for my web, iOS, and Android apps. And what's especially cool about my code is that it's in a Git repo hooked up to a CI/CD pipeline. That means after we write our Model Context Protocol server, we can push our code to the dev or staging branches to test it before it actually goes into production, while Savala automatically handles all the deployments and cache busting for us automatically. And now we're ready to jump into some code. Here I have a Dino project, and the first thing you'll notice is that I'm importing a class called MCP Server. This comes from the official SDK, but if you're not using TypeScript, they have a bunch of other languages like Python, Java, and so on. We'll also be using Zod here, which is a tool used for schema validation, which allows us to provide a specific data shape to the LLM, so it doesn't just hallucinate a bunch of random crap. Now, after we create a server, we can start adding resources to it. The resource will first have a name, like horse is looking for love, and then the second argument is a URI for the resource. Then finally, the third argument is a callback function that we can use to fetch the data. In this example, I'm writing a query to our Postgres database, which is hosted in the cloud on Savala, then accessed on the server with the Postgres.js library. But you could access any data here. When something is a resource, though, it should only be used for fetching data where there's no side effects or computations. If you do have a side effect or computation, you should instead use a tool. Like for horse tinder, we might want the AI to automatically create matches and set up dates between horses. We already have a RESTful API endpoint that can handle that, and we could actually leverage that code here, essentially creating an API for our API. In fact, many of these MCP servers are actually just APIs for APIs, and that sounds like dumb over-engineering, but having a protocol like this makes it a lot easier to plug and play between different models, and just makes LLM apps more reliable in general. Case in point, notice how I'm using Zod here to validate the shape of the data going into this function. That prevents the LLM from hallucinating random stuff here. Basically, when you prompt Claude, it's going to need to figure out the proper arguments to this function, so providing data types along with a description will make your MCP server far more reliable. And then the final step is to run the server. In this case, I'm going to use standard I/O as the transport layer to use it locally, but if deploying to the cloud, you can also use server sent events or HTTP. Congratulations, you just built an MCP server. But now the question is, how do we actually use it? To use it, you'll now need a client that supports the Model Context Protocol like Claude Desktop. There are many other MCP clients out there if you don't want to use Claude Desktop, like Cursor and Windsurf for example, and you could even develop your own client, but that's an entirely separate topic altogether. Once installed, you can go to the developer settings, which will bring you to a config file where you can add multiple MCP servers. In the config file, all you have to do is provide a command to run the actual server, which in our case would be the deno command for the main.ts file where we defined our server code. You'll need to restart Claude, but then it should show your MCP server is running. In this case, my horse is running, which means I should probably go and catch it. Then you can go back to the prompt screen to attach it. That's going to fetch the resource from the server so Claude can use it as context in the next prompt. And because Claude is multimodal, you could also add PDFs, images, or anything else to the context really, like all the horse images in our Savala storage bucket. And now magically you can prompt Claude about things specific to your application. Like if we want to find out which horses are single and ready to mingle, we can make a prompt like this, and it will use the context that we just fetched from our database. Then if we want Claude to write to the database, we could make a prompt like this, where it'll connect two horses from the context on a date. You'll need to grant it permission to do this, and then Claude will automatically figure out which data to send it based on the schema we validated with Zod. And it'll use our server tool to mutate data in the actual application. I can't imagine anything ever possibly going wrong here, and Anthropic is extremely bullish on this being the future. Like their CEO just said that 90% of coding will be done entirely by AI within the next 6 months, and nearly all code will be AI generated within a year. I'm gonna go ahead and press X to doubt there, and I think it's only a matter of time before some AI agent accidentally wipes out billions of dollars in customer data, or becomes self-aware and just deletes the data for fun. That being said though, there's all kinds of amazing tools being built with MCP right now, and you can check those out on the awesome MCP repo. Just please make sure to vibe code responsibly. Huge thanks to Savala for making this video possible, and enjoy this $50 stimulus check to try out their awesome platform. This has been the Code Report, thanks for watching, and I will see you in the next one.